working as a design manager at Eton Aerospace. Without taking much more time, I welcome you, sir, on behalf of Bharti Vidyapit, deemed to be university. I request you, sir, take the charge of the session. Thank you, sir.
Thanks, Bharti Vidyapit, for inviting me to present this topic. I'll just go through my slides. In between anything uh, query you have, just pause me there. I can answer you, or I can take you these slides. After the slides, we can answer those questions. Okay. Good afternoon, all.
Yes, sir. No.
Okay. So as sir mentioned that my profile is B mechanical and completed PG in business management. Currently working with Eaton from last 15 years. Before that, I was very small company, special purpose machine. So total experience of 16 years plus. I'm working here as application and system design. I am actually giving a training, hydraulic training, application training. Automation Studio is one of my core strength. I was visited Brazil for a project for a couple of months, so I know Portugal language like verbal only. So this is my contact details. So today's agenda, what I planned is like simulation in industry, automation studio, hydraulic system, automation studio. A few example I wanted to share, and Eaton application using these tools. This is more important for faculty to know what industry is doing with this tool. So power, and lastly the power and capability of tool. One of my family colleague I invited to share some new upgoing developments related to automation studio. He is going to share you if he joins there. Okay. So what is simulation industry? So basically, we know that hydraulic is in broader sense, it transmit and control of forces and movement by controlled pressure and flow. So it's a basic definition of hydraulic. And what is hydraulic system? Hydraulic system is means by using a pressurized fluid, mostly oil or water, to transmit power between the place where the power is generated and the point where it is used. It's a basic fundamentals of hydraulic system. So I'm not taking much time on defining the hydraulic. So what we are knowing is like hydraulic system, wherein it's a power generating tool. So from which we do lot of applications. So we maybe yesterday you might be learned about hydraulic circuit building through Automation Studio. This is the one application where single pump connected to cylinder, wherein single pump connected to motor, similar way. So if I connected a single pump with one single cylinder, then my simulation is comes like this, wherein I can read linear velocity, pressure, and the power consumptions. So these are the basic simulation we can develop through this tool. Similarly, if I use two motor, then there will be some difference in graphs, wherein I can use single motor, then it will be difference in graph. So these are things we are finally used in our industry. So any query in this? Okay. So before jumping to the application, I just like to have some key requirements while designing a hydraulic system is like we need to know application, speed, force, cycle time, or limitation. Any restrictions are there, then we need to know that to design a circuit. While selecting a component, you need to know flow handling capacity, working pressure, control accuracy, control type, atmosphere at the application. So we know all these basic formulas used in hydraulics, power calculation, cylinder force, speed requirement. These are the basic one, just I wanted to glance there. So the thing is like automation studio in hydraulic system. So let us take one example where I wanted to crush my car. Okay. So this is the before crushing the car and after crushing the car. So let us take this example wherein there is an electrical motor connected to, sorry, okay. Oops. Actually, let me see. There is an electrical motor connected to hydraulic pump and flow control valve and everything. So the application is to crush the car, but it is not crushing. Looks like there is a problem in the circuit or the PPT. No, actually this is a basic simple circuit wherein we can understand that crushing the car with a simple simulation. Consider an example wherein I have multiple cylinders wherein metal industry applications. So earlier case we were having only 2 cylinders where I'm going to crush my car, right? So here multiple cylinder. I don't know which cylinder moves faster with this system. It's very difficult to analyze that. So one of the best application I can use it Automation Studio, wherein I can use this tool to analyze which moves cylinder fast or I can control fast, how to manage the application kind of a thing. This can be very easily studied and understand based on the application through this Automation Studio. These are the very basic thing. The next slide I'm going to show you the real application what we do in industry. Till today, any questions? Okay.
No, sir, continue, sir.
Okay. Yeah, it's a very difficult. It's not a difficult to understand. So maybe now I'm showing my applications wherein might be having some questions. Let us understand one of our application is Eaton screw-in cartridge valves. Okay, we have that catalog wherein we have multiple valves. This is one of the screw-in smaller division, but very complicated circuit we used to develop through these valves by using for backhoe loader or application like JCB or excavators. So those kind of application we use this kind of smaller package valves. So during my working application projects, I used to get confused using these valves because this catalog do call out multiple version of controls wherein P means spool where has a load sense element, V spool NC normally close, R spool pressure reducing. It's very difficult to understand which configuration I need to use this application for my application. So that's a question arrived with me. Then I currently work with the multiple graphs. Along with that, there are multiple graphs with these spool configurations. So it's very difficult to analyze which spool is better compared to my application. Then I put that circuit in Automation Studio, wherein I connected those all spools V, R, F. Those are the keys which I wanted to understand how my application works. So with the same pump flow, I connected these relief valves with this different spool configuration of valves with load holding proportional valves and connected to the motor. By this way, I can control the joystick. I can understand what is, if I run the simulation, maybe after this I will show you some videos wherein you can understand how these videos or application circuit works. So by connecting this simulation on, I can understand this spool, the V spool will give me 42 bar pressure with a speed of around 9,000 RPM, wherein R gives me 14 bar delta P with the speed of around 3500 RPM. With this spool, FF spool will give me 3 bar to get around 900 RPM. So based on my application, I've selected FF spool because I need a low pressure in my system. So that was very easily I can get it from this tool through Automation Studio. This is one of the criteria we used to use Automation Studio. The another example is injection molding machine. It's a very critical application wherein we know that in injection molding machine, there is a fixed RAM. The another is moving RAM. So the injection cylinder will move on inside the die. It will inject the material inside the die. So we will get the end result similar to like plastic buckets and everything. So this circuit I developed in Automation Studio. It was a basic training for people. I just developed this circuit. It's not for industry. So it's very easily to understand the sequence of these walls. I've just run through the videos which I'm having. I'll show you that. Actually, my speed is okay, or still I need to reduce? How is the speed?
Yes, it is good, sir. Hello?
Hello?
Yes, it's good. You can continue.
Okay. See, I'm switching on we can take videos of this tool wherein you can understand your students, or you can teach very easily how the hydraulic circuit works. During my college days, I didn't get a chance to see these kind of applications and circuits. We were facing a lot of issues while understanding the basic relief valve. But this tool help your students can very easily understand the circuits, how the relief valve works, when the check valve should be open like that. So basically, this circuit are developed to show that there is a pump, there is a tank. These are called relief valve unloading circuit, which has multiple cylinders, pull-in cylinder, injection cylinder, screw drives, auto tonnage circuit, clamp cylinder. These are the cylinders are connected to these images. Are you with me? Okay. So just electrical diagrams, whatever the solenoids are shown in this circuit are connected to this sequence of the cylinders. So that when I'm switching on this button, I can run this circuit. I'll show it again. See, this clamp cylinder is moving. This picture is moving. Pull-in cylinder, then pull-in cylinder will move. This injection is rotating. So injection cylinder is injecting the material. Return. Same way, similar way, this all electrical diagram also switching on off based on my sequence, which I listed here. Do you want me to show this video again? I'll just, for the interest, I'm just showing that. For this way, you can build a multiple machine circuits with electrical diagrams, so that we can understand the application very easily using this tool. Okay. One more application wherein we use hitch control valve. It is Eternize product, and we were using this hitch valve to operate the tractor's backside, what you got, trolley. wherein you can take the mud whenever while soiling out kind of a thing. So there are couple of circuits I developed through this to analyze the application. See, by controlling this steering wheel, I can control this spool so that my tractor wheel or steering control wheel will rotate. This is a simple video. I'm just showing that this, by operating this, we can operate the hitch wall. I don't know why this video is not working. Okay. So basic understanding is this hitch wall also works based on the application by switching these controls. This was a basic circuit we wanted to show to our customer to develop their confidence. These are multiple ways we used to take our projects to show our customers to win the confidence so that whatever application circuit we developed are working. This should be initially we can check before releasing the drawings to the actual one. There is a basic need for these kind of circuits simulations. This is one of the complex circuit we have like CLS, uh, which has individual stacks which are mounted in this block. You can see this picture. Each block has different walls configurations. These are these walls. Maybe whenever you get a chance, you can see that where JCB person was operating those levers. Basically what he is doing is he's operating this lever to control these circuits, to operate cylinders or motors or swing, any operation he was doing. I just show you the one video wherein I can tell you that how this circuit works. All the same video I have. These are the joystick. Whatever these are blocks coming are joysticks. I'm just clicking on the joystick so that the operator is operating these sticks. Can you imagine that? The cursor which I'm moving is just to show which cylinder or which joystick I'm moving. By switching on the switch, I can change the speed of the motor. That's the reason we can manipulate whatever you want here before releasing actual one. That's a simulation we use this tool to analyze. The same tool, the same circuit I can use it for what do you call drive the wheels. We can drive the wheels based on the rotation. We can take a rotation of the wheels. We can do that way also. These are the things. One wheel we can hold it, another wheel we can rotate so that my steering radius can be reduced. That kind of application we can play here and we can develop that. So one of the requirement from customer want to understand how the CLS configuration works. So we gave them explaining through these videos and win those confidence. Okay. Similarly, one of the project similar application. Yeah. See, initially, if I'm switch on this simulation, I can read that this. I can switch. I can hold this. Whenever I'm switching on this, the same pump flow, whatever it's going through neutral with all the stacks. We call this as a stack wall. So it will go like this. So initial condition, nothing will be moved. Whenever I'm operating this joystick, then only the cycle starts moving cylinder or rotating the motor. You can see that we called as a neutral pressure. Yeah. Can you able to see this? This I'm holding this. I'm just moving this wall so that my cylinders are moving. Very beginning of this slides we shown that only car crash, but here there are multiple cylinder, multiple walls. It's very difficult us to develop a circuit without simulation. So this is one of the tool we can utilize to analyze the application. We are not 100% sure, but still at least 95-98% we will get confidence through this tool. And for developing such circuit, it will take hardly 4 to 5 hours if he's expert. So that it's just you can pull out the symbols and connect it and configure it. It's not a big task, but when you have expert, then we can do it very easily. Okay. Coming back to the circuit. Okay. So these are the tools which we used, uh, like manual control valve, wherein we can see in JCB or backhoe loader or excavator, people are manual operating those valves so that they can simulate. Here this tool also help us to understand the curves. Whatever the flow paths are designed in my circuits or designed in my catalogs, whether it is providing those data or not. This can be helped. We can analyze through this tool also. It is one way, we can say one level down to understand how this pool configuration works. Who is not help to the wall designer, but the application engineer. We can see that whether the flow path or flow passes or flow paths or pressure drop or anything, flow forces, we can see these graphs through this simulation. Maybe something like they are actually, FAMIC is developing one more tool wherein we can connect 3D versus this simulation, wherein you can operate this simulation hydraulically, and your excavator is taking up the material or lifting like that. So these kind of simulation also you can develop through this automation studio. Any question till now? Hello? Hello?
Uh, Hello, any question from participant? Ask one by one by unmuting itself. Any question from participant? Sir, no problem, sir. You continue, sir.
Okay. Actually, one of my colleague from FAMIC is also joined. His name is Shadul Admin Amin Shadul. Hello. Shadul is there. Actually, you can check whether he joined or not.
Yes, sir. One Shardul as a guest has joined.
Shadul. Yeah.
Yeah, Shardul as
Shadul.
guest. Yeah,
Yeah.
Yes,
His wife.
Mr. Shardul.
yes. Can you hear me?
Yes, yes, sir.
Yeah.
Your voice is
Shadul.
audible.
Yes, sir. Here.
Shadul, can
Great.
you show the latest trend? What is going on in FAMIC related to Automation Studio and in other industry? What you played, so that faculty team will be happy to see that.
Definitely, definitely.
Yeah.
Uh, Yuvraj, you can
So,
give the control to
Yes,
Shadul.
sir. He's already. I have made him presenter. Can you just
Okay.
stop your presentation so that he can present?
Okay.
can you see the screen?
Yes, sir.
Yes, 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 you can.
Okay. So, first of all, good evening, everyone. My name is Shardul. I work in
Good
FAMIC
evening, sir.
Technologies. Yes, good evening. I work in FAMIC Technologies Automation Studio Software as technical sales and support in charge. So, I'll be talking about Automation Studio, its applications in different industries, and how the software has evolved over time. So, first of all, thank you, Mr. Anil, for showing the videos of Automation Studio, how you use it in your company. So, if you see Automation Studio, this is a software which combines different technologies like hydraulics, pneumatics, electrical, PLC. So, to start with, I'll just give you a brief about the software. So, just give me a minute. So if you can see the screen, this is a very important wheel that gives you the features of the software. So the Automation Studio software is a combination of fluid power, that is hydraulics and pneumatics, with your electrical circuit designs, electrotechnical drawings, and your automation part, that is your PLC ladder logic and SFC. SFC is sequential function chart. So in and all, it is a multi-technology software including fluid power, electrical, and automation technologies on one single platform. So what Mr. Anil has shown is majorly concerned with hydraulics. He has shown you most of the videos and the applications regarding hydraulics. I will be showing you different concepts and different technologies in Automation Studio software as well. So just to give you a brief about the software and its usage in different companies, I'll just show you a partial list of clients. So right from agriculture, construction, mining, aerospace, transportation, as well as training centers, the software has applications in different sectors. For example, like Mr. Anil said in JCB, also if you consider an entire excavator, that entire excavator can be designed in Automation Studio. Similar to that, if you see tractors from CNHI, you have a plant in Pune, John Deere also you have a plant. So the entire tractor hydraulics transmission systems, all those things can be designed and simulated in the software as well. Also, when it comes to mining, Komatsu Mining is one prominent company in Pune which uses the software. So there are a lot of companies in and around Pune and Mumbai who have been actively using our software for their designs and simulation purpose. So coming to the industry-wise uh, use. So if I tell you about the industries, so hydraulics is something which is used in various industries, right from agriculture, construction, mining, oil and gas, to material handling, and so on. When it comes to pneumatics, you have uh, a lighter application. You have to lift small weights. So in the packaging industry, mainly pneumatics comes into the picture. And also when it comes to organized sequence, or if you want to implement a particular sequence of your operations, for that you have your automation part, that is your PLC ladder logic. You write a program, and according to that program, a particular sequence has been followed. Now another important factor when it comes to any industries is your electrical side. So the software also has an electrical module in which, let us say, you see a conveyor line. A conveyor line is attached to a motor, three-phase motor, to a control panel as well. So the even a control panel, a three-phase motor, AC circuit, alternating current, DC circuit, all those circuits of electrical as well can be implemented and can be drawn in Automation Studio. So now I'll go step by step, as in what all things you can do using Automation Studio software. So any questions so far? So I hope you can see my screen. Can you just confirm if you can see my screen?
Yes, we can see that.
Okay. So this is the interface of the software Automation Studio. If you see on the middle, you have a screen for drawing your schematics. On the left hand side, if you see, you have the library explorer with different libraries: hydraulics, pneumatics, electrical, PLC, electrotechnical, blocks diagram, HMI, and control panels as well. Whereas if you go to the right hand side, you have the project explorer with different project being opened and the diagram associated with it. On the top left, you have different tabs: home tab, simulation tab, fluid tab, technical training material, and so on. So this library is formed in a tree structure. If I click on hydraulics, it will open up the different folders with different components here. So let us say I quickly make one hydraulic circuit, basic hydraulic circuit here. I take a unidirectional pump with shaft. I'll take a double acting cylinder. I'll take a electrically controlled directional control valve, and I'll take a relief valve. Now let us say that if you are not knowing the use of these components, for the students who are new to the software, so what they can do, they can just double click on any component, and when they double click on it, you have the help icon here. So you can click on the help icon. So when you click on the help icon, the software will automatically give you the operation of this particular component, as in how unidirectional pump with shaft works, what is the application, how does it function, and so on. When you click on the data tab, you have different parameters to play with, like displacement, pressure, and so on. So this applies to each and every component here. Now, if I just easily join the lines here, I'm just connecting my cylinder to the DCV, the DCV to the pump, and this is my relief valve, which is a safety valve, to the pressure line. And now I need reservoir, because in hydraulics you have to have a hydraulic power pack, or where you have a reservoir from which the fluid is sucked by the pump and then supplied to the actuator. Now, if you observe that in this particular circuit, the shaft is open. So to drive my pump, I need a motor to drive. So for example, if I need an electric motor, I can just type here electric motor in the search box and the electric motor will appear. Now, as I join it, you will see that my basic hydraulic circuit is ready. Now, if I go in the simulation tab, start the simulation, you will see that different colors show the different pressure levels. For example, if I click on the relief valve, currently my pressure is at 80 bars. If I start to increase, you will see the color will change. So the different colors are basically decided according to different pressure levels. If I click on the left spool, cylinder will extend. If I click on the right spool, cylinder will retract. So basically this directional control valve decides the flow of the direction here. And also to understand the components in a detailed way, you can just right click on it, click on animation. So you will see the cross-sectional view of those components. For example, this is a gear pump. This is a relief valve. This is my cylinder. So you will get to know how it actually looks in the cross-sectional view. Now moving ahead, a lot of companies, a lot of industries use this software for different measurement purpose. So for that, we have different measuring instruments here. So let us say if you want to see what is the speed of the cylinder while extension. So what you can do here, you can just click on the first measuring instrument, component dynamic, click on the cylinder, just drag it here, and it will ask you which property you want to measure. So let us say you say linear speed of the cylinder. You can also select the unit you want, centimeter per second, meter per second. You can also select the precision level. So now if I extend, you will see that the cylinder extension speed is 43 centimeters per second and the retraction speed is around 57 centimeters per second. Now, if you want to measure different pressure levels, so you can take different measuring instruments, you can just add it here. So these measuring instruments are really very useful for watching the dynamic simulation properties change with respect to different parameters. For example, if I now see I have a pressure of 120 bars here. Now, if I increase the pressure of the relief valve here, you will see that the pressure will start to increase. So this is how dynamically the properties are changed here. Also, if you see in the real life, you have different parameters or different equipments to check different properties. For example, if I take a hydraulic tester, so you have hydraulic testers, you can just take different probes, place it on the position that you want, and you will see the different pressure values here in the hydraulic tester change. Similarly, you have different pressure gauges as well. You have thermometers as well to check the temperature at a particular point here. So all these things are really useful for measuring different systems to check the behavior of different systems during simulation. So I hope this part is clear. Any questions so far? Fine. So moving ahead with this, there is another important feature that we have here is plotters. So what if you want to see in what time your cylinder extended? Or let us say, I'll just show you what kind of effects different parameters have in the software. So I'll take another double acting cylinder and I will place it over here. Okay. Now once I place it over here, just give me a minute. I will make the pressure line connect to the cylinder. So these are my two cylinders. Now what I will do in the second cylinder, I'll double click on it. I'll click on the data tab. and I will put some load on that cylinder. So let us say that cylinder has to push a load of 100 kgs here. So I'm adding a load of 100 kgs and I am giving an inclination of 45 degrees to the cylinder. So if you now observe these two cylinders, my second cylinder has a load of 100 kgs and it is inclined at 45 degrees. So let me just make the inclination to 45 degrees. So I hope now this is much more clearer that these two cylinders we have in the line. Now let us see the effect of these cylinders when they extend. How will the extension time change? So if you go in the simulation tab, we have three different types of plotters. First is y of t plotter, which is a plotter used to plot a property with respect to time. Second is y of x plotter, which is used to plot one property with respect to another property. And third is z of xy plotter or a 3D plotter for three different variables with respect to each other. So I'll take a y of t plotter first. Now what I have to do, I have to just drag and drop this cylinder on the plotter. I'll select the linear position here. I also drag another cylinder and I will check the linear position here. And now if you observe, the yellow line is for the first cylinder and the blue line is for the second cylinder. So now if you have to see what is the effect on the simulation on these two cases, so what you can do, you can start the simulation. You can click on the left spool and you can also retract. Now after one stroke, I'll stop the simulation. So now if you observe here, these are my two curves. My yellow curve is of the first cylinder on which I have not put any load, whereas my blue curve is for the second cylinder where I have put some load. So if you observe now, the yellow line here extends first. So this delta t here shows me the extension time of the first cylinder, that is around 1.59 seconds. But if you see, my second cylinder extends later. It comes to the extension phase here after 2.341 seconds. Now why is this so? So you can easily make the students explain or understand the concept that when the cylinder is inclined at 45 degrees, it is acting against the force of gravity, and also we have added a load of 100 kgs. So this cylinder will require more force from the fluid to push against the 100 kg of load and 45 degrees inclination. So that is the reason the second cylinder will extend later, whereas the first cylinder will extend first. Whereas if you see the retraction time, if I change the cursor to the retraction part, you will see that the retraction of second cylinder, that is this cylinder, is first, whereas the retraction of the first cylinder is later. Now why is it so? Because during retraction, the 100 kgs of load is acting as a driving force. It is acting towards the retraction part, and also the gravitational force is acting as a driving force when it comes to retraction. So that is the reason the second cylinder has retracted first, whereas the first cylinder has retracted later. So such kind of concepts and such kind of analysis can be done in automation studio software. Also, if you can see, the second cylinder doesn't have a smooth linear curve of extension. So there is some problem with the extension of the second cylinder. Maybe you need to increase the displacement of the pump, or you can increase the system pressure. So all these things can be analyzed and viewed during the simulation. So I hope this part is clear for you. So if you have any questions, you can ask me anytime in between. Fine. So if you don't have any questions, then probably I will move on to the next technology, that is pneumatics that we have. So for example, in pneumatics also we have the libraries like this configured like in hydraulics. So you can take a pneumatic pressure source. Now obviously in pneumatics you need compressed air instead of fluid. So you have a pneumatic pressure source or a compressor that you can take. You can take a single acting cylinder, and you can also take electrically controlled directional control valve. I'll just make the connections. Now, why this software is really useful in industries is because the accuracy level of the simulation is very high compared to other softwares. For example, if I double click on any line here, these lines that you see, these lines are just not the CAD lines. These are actually the hoses and pipes used in industries. So you can set the material of that pipe, you can set the internal diameter of that pipe, you can set the length of that pipe, and accordingly, the simulation results will change. The pressure drop will change. So in this pneumatics part, I have taken a pressure source, that is a pneumatic pressure source. And if you see in the return line, I have added an exhaust. So this is an exhaust. So it directly goes to the atmospheric air. Whereas in hydraulics, we have the reservoir. Now, if I start the simulation, you will see that this is my pneumatic line. If I click on the left spool, cylinder will retract, it will extend. So similar to what we saw in hydraulics, pneumatics also has similar components like in hydraulics. The only difference is you have the pressurized air coming through the circuit here. All other things like measuring instruments and simulation parameters remain the same. So I hope this is clear for you. If you have any questions on the pneumatics part as well, you can ask me anytime. Fine. So let's move on to the electrical controls now. Now, let us say you have your hydraulic pneumatic system in place, and now you have to give electrical supply to them. So how can you do this in Automation Studio? Now, a lot of companies find this useful because they want to make an entire circuit controlled electrically, or they want it in a sequence for that as well. So for that, what we have is electrical controls. So if you see on the left hand side, we have different libraries: electrical control JIC and electrical control IC. So JIC and IC are basically two different standards which are used in Europe and America as per different standards for the designs. So I'm using the IC standard. I'm just taking a 24-volt supply here. I'm taking a normally open push button. Let us say I name the push button as S1. I take another push button and I name it as S2. Now these push buttons are like the usual buttons that you press. You press the button, the electricity is on. So these are your push buttons. And then I take the solenoids. Now these solenoids, I'll name the first solenoid as extend. And the second solenoid, I will name it as retract. I'll just place it properly so that you can see it. And at the end, I'll place a 0 volts or a ground, you can say, and I will make the connections. Now these are my electrical connections that I'm making. directional control valve and I click on the left solenoid, so I have something for variable assignment. So I will just link it to the solenoids of my electrical part. So I have named the second solenoid as retract. I can just type here retract. The software will automatically give me the solenoids here. So if you see now, there is a blue color appearing for the solenoids. That means these solenoids are hyperlinked. So if you plus just control plus click on it, you will see that these are hyperlinked. Similarly, for pneumatics, we will also link it. So the directional control valves in pneumatics are also solenoid operated. So you can just link it to the required solenoid. So now if you observe, I have created a electrical control circuit. I have created a hydraulic circuit in the middle, and I have created a pneumatic circuit here. Now if I start the simulation, now let us say I am pressing the S1 button here. So what will happen if I press the S1 button? This solenoid will get charged, and this solenoid will give a supply to my solenoid of hydraulic DCV, which will push the solenoid to this position and which will actuate the DCV. Similar to the pneumatics, it will give a supply to this particular position of the DCV. So if I press the S1 button, you will see that through electrical controls, a hydraulic and pneumatic circuit is operated. So I hope this part is clear so far. So if you have any questions, you can ask me right now. So we can move on to the next technology as well. Fine. So I don't see any new questions coming up. Okay. So let's move on to the next part. Now let us say you have made the hydraulics part, pneumatics part, electrical controls, and the next part is you want a sequence. You want a sequence for your hydraulic or pneumatic circuit to be performed. Then what will you do? How can you do an entire sequence of your operations? So for that, if you see on the left hand side, we have the PLC module. So that is ladder for Allen Bradley PLC. We also have the Siemens PLC ladder. We also have LS Electric PLC, and we have IC standard PLC ladder logic as well. So if you see, if I click on the AB PLC, you have the rung, you have the normally open contacts, close contacts. So you can just take these things here and you can start to build your own PLC circuit as well. So I'll just place my pneumatic circuit upwards. So if you observe here, you have your entire PLC circuit, and you can also have your input and output cards. So let us play one file that I have, which I will show you how PLCs are implemented in Automation Studio. So this is with the Siemens PLC software. So if you see, this is how your PLC looks like with input cards and output cards. On the output part, you have different solenoids here again, which are linked to the hydraulics or pneumatics solenoids. And this is your 3D interface. So this is what we call Unity 3D in Automation Studio. So Unity 3D is a software for animation purpose, for giving you a good virtual 3D experience. So what we have done here is the entire logic of this particular machine is developed in Automation Studio, even the PLC logic. If you see the cylinders here, A, B, C, so these cylinders you can take in Automation Studio, and then you can write the PLC program for this kind of machine. So in this particular project, we have done the PLC programming. Also, we have taken the help of Unity 3D software for a good virtual experience. And this is my Siemens TIA portal, in which we have combined Automation Studio PLC with the Siemens PLC. So Automation Studio can also communicate with different softwares. So let us say if you are using Siemens PLC software for preparing or making different logics, then you can also link those uh, PLCs to Automation Studio PLCs for getting an experience of your entire machine, a virtual experience. For example, in this, if you see, cylinder A extends, then cylinder C drills, then cylinder B pushes that block. So this is an entire sequence that has been driven or that has been created using PLC ladder logic. So the entire proximity switches, proximity sensors, which are used on the top of the cylinders, is created in Automation Studio. So the proximity sensors basically sense the position of the cylinder. They give the supply to the switches, and the switches in return give supply to the input cards of the PLC. And then the output cards, which are having solenoids connected to them, gives the supply to the solenoids, and then they change the position of the directional control valve, which in return changes the position of the cylinder. So that is how you can see that you have one PLC project that you can create entire project using hydraulics, using the PLC logic and electrical controls as well. So I hope that this part is clear so far. Now coming to another part here is, let us say you have a virtual PLC, an actual PLC on your lab. If you're using Siemens PLC or AB PLC, then you can actually connect that PLC to Automation Studio PLC tags as well. So for example, in this particular uh, video that you see, you have the Allen Bradley PLC drilling factory control. But in this, we are giving manual input. So I am pressing on C, then the cylinder C will extend. I am pressing on the C minus button, it will retract. So we are using it manually through Automation Studio. Now, what will happen if we do it through a actual PLC? That is the hardware PLC. So in this, what Automation Studio has to offer you is, this is your PLC, this is your buttons, and this is your RS Logix 500 software for PLC programming, Allen Bradley. So what we have done here is we have incorporated their PLC program with our PLC program in Automation Studio. So you can link the tags, and then through the signals from the hardware PLC, the actual machine can be operated. So this is what we call software hardware interface as well. So the advantage that you get here is you can create an entire virtual project in Automation Studio, and then you can test the logic, PLC logic of that entire machine in AS. It will not only limit you to PLC programming, it will also give you the freedom to make your hydraulic and pneumatic systems as well. So I hope so far it is clear for you. If you have any questions, I'll wait for now, or else I'll uh, move ahead.
Participant, any question regarding that? Please ask them one by one by unmuting itself. Any doubt regarding that? Ask them. Sir, continue.
Okay. So moving on, as I told you that this is multi-technology software with different applications here. So I'll just show you one example in which you will get to know what all technologies are involved in this automation studio. So if you see this particular file here, now this is a combination of all different technologies. So your entire system you can build in Automation Studio, you can simulate and see if it is performing well or not. So if you first observe in this system, you have a cylinder in the HMI animation part, and you have a block here in which a drill has been made. Now what we have done here is we have taken a hydraulic circuit. So this particular cylinder is linked to my animated cylinder here. If you see, we also have a pneumatic part. So this pneumatic part is basically to clamp this particular block here, which is going to be drilled. And if you also observe, you have the HMI control panel feature as well. So whenever an operator comes to a shop floor or a machine, he has such kind of control panel to press certain buttons which will activate different electrical circuits and hydraulic pneumatic circuits as well. So if you observe, if you click on the start button, automatically this particular electrical supply will start, this button will start, and it will give a signal to the input card of the PLC. Now we have an entire ladder logic written here. We also have the timer, as in till what time it should drill, till what time it should drill and then come back. And also if you observe here in the hydraulic circuit, you have the electrical motor. Now this electrical motor is a three-phase motor with three-phase supply. If you see L1, L2, L3, this is my three-phase supply coming here, which will drive the motor. So now if I start the video again here, if I click on the start button, so the entire sequence can be created here. So if you see here, we have set up a time of 3 seconds. So for 3 seconds, the drilling will be done, and then the sequence is being executed using the PLC program. The logic sequence can be controlled here. If you see, we have different sensors mounted on the cylinder as well. which will sense the position. And for the emergency stop also, we have given emergency stop button as well. So this particular file will show you the entire operation. I mean the entire technologies that we have in Automation Studio, whether it is hydraulics, pneumatics, electrical, electrotechnical, PLC, the 3D part as well. So this will sum up all the technologies which are used in the software. Now let us move on to the application part. So we'll start with maybe hydraulics first. So I'll just open few files which will give you a brief or give you an overview of different types of applications here. So for example, like Mr. Anil said, for the 3D Unity part of an excavator. So if you observe this particular circuit here, we have the entire excavator circuit built in the background here, whereas the 3D part is done in Unity 3D platform. So this is your entire excavator. And now if you observe properly, this is my load sensing pump on the left hand side. You also have different swing drives. You have different cylinder for bucket, arm, boom. If you see, you have bucket, arm, and boom here for the excavators. You have the load sensing pump in the excavator, which will give all the required force and the pressure. You also have counterbalance valves with some check valves also, so that it shouldn't fall in one way. The load should be balanced. So the entire hydraulic circuit, which is required to drive the excavator, is built in Automation Studio. And what we have done here is, for the animation purpose, we have done it in Unity 3D, which will help the user to understand how important the circuit is, and according to what changes you are doing, how the machine is behaving. So I'm just starting this video. So if you observe, depending on the cylinder position on the boom bucket arm, the position in the 3D part will also change. So the software is mainly also used in such industries for teaching and training purpose. For example, the new freshers who join industries where excavators are made, if they want to teach them what is a hydraulic circuit behind them, what will happen if you trigger a particular control, which valve will activate. So all these things which are helpful for training purpose, which will also affect the safety of the operator in the future, the required training can be done using Automation Studio software. So this software has multiple benefits. Apart from teaching and training, you also can design and simulate your entire circuit in Automation Studio as well. So like I showed you, these are some files with generic library components. So what I have done here is, I have taken components from the libraries, but we also have different manufacturers catalog components. For example, which Anil sir showed you, the Eaton components. So we have an entire catalog for different components of Eaton, for Bosch, for other manufacturers as well. So I'll just play one file which we have built using the components from different manufacturers. Now, if you observe, you might have seen hydraulic press. A hydraulic press is used in a lot of forging industries, steel industries as well. So one of the applications that you will see of this software is in Bharat Forge. So in Bharat Forge, you will see such kind of hydraulic presses here. You will see that on the left hand side, you have the entire hydraulic circuit made in Automation Studio. You have a slip-in manifold valve here. Think these valves are from Eaton. The manifold valves here, the entire block, manifold block. And we also have different valves from different manufacturers used in this particular file. Now, what happens is if you use a particular component from a particular manufacturer, this will definitely affect the efficiency of your simulation. This will affect the accuracy of the results that you get through the software. So if I just start this video, so you will see the 3D model is also animated. Plus also you will see that the hydraulic circuit works as per the circuit design. And you also have an entire sequence being built in PLC. So which cylinder should extend first, then the gate should open, then the block should be pushed. So to have and execute that entire sequence, we have the PLC program as well. So this is how an entire hydraulic press can be designed and simulated in Automation Studio. Now, another important feature that industries find it useful is for troubleshooting purpose. So for example, let us say you have made your hydraulic circuit, and if you want to find faults in your hydraulic circuit, if you want to see if there is any fault or not, then how can you see it? So for example, if I just delete this, I'll just show you how you can do this. Now let us say this is my hydraulic circuit in which I have a double acting cylinder. If I click on the double acting cylinder and click on the data tab, I have a property of defining the maximum pressure here. So currently the maximum pressure defined is 450 bars. Now if I change it to 200 bars here, so that means the maximum pressure withstanding capacity of this cylinder is 200 bars. Now if I go in the project properties, I have an option for monitor faulty components. So I'll just click that option. And now if I start the simulation, you will see that the cylinder is extended and retracted in a proper way. So if I just check what is the pressure at this particular point that is coming to the cylinder. So this currently is at around 72 bars here. Okay. Now what will happen if I increase the pressure to beyond 200 bars? So remember that we have set a maximum pressure of 200 bars for the cylinder. Now if I increase the pressure to, let us say, 280 bars. So practically the cylinder should not withstand a pressure of 280 bars. So what will the software do? So if I now click on the start button, let us say I again extend the cylinder. Just give me a minute. Now I start. So you will see that you have a faulty sign already coming up, which means that there is some problem with the cylinder. Now, how can an industry person diagnose this problem? So what he'll do, he'll check the pressure at this line. He will check the flow, what is coming on this line. He will see different properties. If there is a problem with this particular line, or if there is a problem with the directional control valve, or if there is a problem with the pump. So he can troubleshoot different scenarios in Automation Studio. And later, if he observes and sees that there is a fault in the cylinder, so maybe he can play with the cracking pressure here. So if I just reduce the cracking pressure below 200 bars, you will see that the faulty sign will go off. So that means there isn't any problem in your circuit now. So such kind of troubleshooting can be done. Also, you can create different scenarios in which, if suppose there is a leakage in line, you can also define the leakage. You can also jam your piston. You can also create different failures in the lines, in the relief valve, in different components as well. So such kind of troubleshooting scenarios are also very useful for the industries to test their system before actually assembling it or manufacturing it in the real life. So I hope this part is clear for you. So moving on to another important thing, we have created, we have introduced a new module in the software, that is Mechanism Manager. So if I just show you what Mechanism Manager does and how it is useful for you. So I'll just open a particular file here. So meanwhile, if you have any questions, you can ask me anytime.
Hello.
Yes.
Yes, sir. Hello, sir. This is Vishal Ghatke from Aurangabad. I have one question regarding this software called Automation Studio. Sir,
Hmm.
if we made a PLC diagram in electrical CAD, so can we import that file into this Automation Studio and then we can simulate? Is there any option to import and export the file?
So if I click on the export, so you can export these formats. So what is the extension of that file, the format?
It's AutoCAD file, DWG.
DWG. Okay.
Yes, yes.
Yeah. So DWG file can be imported here, AutoCAD file, and then you can link it to the uh, files in or the components in Automation Studio.
Okay.
Yes.
Okay. Thank you, sir.
So you have your electrical designs in AutoCAD and you want to simulate.
Yes, simulate in Automation Studio.
Okay. So when you import it in Automation Studio, you cannot directly simulate it, but you will have to, you can make it in Automation Studio, keeping a reference of that file.
Okay,
Yes.
thank
Welcome. Fine. So any more questions? Okay, so I'll move forward. I'll just open this mechanism manager module that we have introduced. So if you now observe, this is my simple lifting mechanism. So if I start the simulation now, you can see that this particular mechanism is linked to my cylinder here. So if my cylinder extends, I am lifting a load. If I retract, it will lower the load. Okay. Now what is new in mechanism manager? For example, if you see, this is a rock in my bucket. Now what if that the rock mass is increased? So if I just stop the simulation and if I click on the fluid module in the mechanism manager, so you will see the entire mechanism is created here. So right from your bodies to your joints to your clampings, pivots. So all these things are defined here in mechanism manager. And if I click on the rock, you will see that currently the body mass of the rock is 100 kgs. Now that means we are lifting a load of 100 kgs here. Now let us say I increase the load of the rock to 2500 kgs. Now that is too high. I know as per the actual real life rocks, but let us try to simulate what will happen if the load goes to 2500 kgs. So now if I start the simulation, you will see that there is some problem in the circuit. If I try to extend, it is not able to lift. It comes back again. So in such case, what we can do, we can increase the displacement, we can increase the system pressure. So let us say I try to increase the system pressure here. So if I increase the pressure, it is able to extend or lift the load. So such kind of simulation where your load is changing or you want to see the load that you need to lift, what kind of hydraulic system you need, or if you want to see the effect of that load on your system simulation. So such kind of simulations can be done using the mechanism manager module, which will help you to define a particular mechanism for a particular operation in which you can change different parameters to see the effect on simulation. So hope this part is clear for you. If you have any questions, you can ask me anytime in between. So let us move on to another subject here, that is the pick and place system. So if you observe, a normal pick and place system can also be drawn in Automation Studio. The circuit behind it can be drawn as well. So if I just open a particular video here, now these are my mains here, the HMI control panel. This is my hydraulic pneumatic circuit, and this is my electrotechnical circuit. So this is my alternating current circuit, three-phase supply coming out here with from the fuses, and it is driving my three-phase motor. So the sequence is managed by the proximity switches on the pneumatic circuits. The electrotechnical circuit is used to run the electric motor. And the SFC chart, that is the sequence function chart, is used for the logic part to manage the sequence. So I hope this part is clear for you. Now moving on to other application oriented or market oriented demos, you have the application in different industries, right? From aerospace to marine to oil and gas to mobile hydraulics, like we saw in the presentation earlier. Now in the marine sector, if you see, I have few files to show you, especially in the oil and gas and marine sector, how the software is used. I'll just play one video here of a crane. If you see that usually on the marine or the oil and gas side, you have big hydraulic platforms here. So these are some hydraulic platforms on which you have big cranes installed. Now the working of this crane is all hydraulic operated with different sequences as well. So the animation part that you see is in Unity 3D that we have built, whereas the entire hydraulic circuit is built in Automation Studio. It is being used and built with different components from a manufacturer called Hydraforce. So in the marine sector, you have such kind of applications. Apart from that, you will see that on the ships you have hydraulic winches. So hydraulic winches are used to lift or lower the load. So all that hydraulic winch application, the circuit design with motor driven hydraulic winches. So all these things can be built in Automation Studio. The software is also used for teaching and training purpose in different oil and gas industries as well. To start with, people are given a basic understanding of different components through the simulation module here. So it has a lot of different applications in the oil and gas and the marine industry as well. So any questions so far? If you have any questions, you can ask me anytime. So moving on to the next subject, like I shown you in on the website, we have different types of applications. So one of them was packaging here. So if you see, usually in a packaging industry, you have different pneumatic cylinders here. You have the conveyor lines with electrical driven motors, the conveyor lines. So the entire packaging system or the bottling system can be made in Automation Studio. The logic part can be built in Automation Studio. For example, if I show you one project that we have created for a company. So if I open this particular project, now this is a bottle filling plant. If you observe here, this is my entire uh, project being created in Unity 3D. And if you see on the top here, these are the pneumatic cylinders. Now these pneumatic cylinders are created in Automation Studio. So these pneumatic cylinders, if you see on the left, you have different pneumatic cylinders created here with different sensors being mounted, and the pneumatic source, that is the compressor driven with shaft, is here. You have the accumulator as well, and then you have the FRL, the regulator unit. So after that, the pressure from the pneumatic source goes through different cylinders. This is my meter in and meter out circuit with a meter in meter out orifices. And then if you observe properly, under that you will see that you have a conveyor line. Now this conveyor line is run by using the electrical technologies, that is your three-phase motor and the control panels as well. And if you see here, we have the HMI control panel, which shows how many bottles have been produced and how many have been rejected. So if I start the video now, you will see that the entire sequence has been followed. So this will help you to simulate and optimize your system. So basically, a lot of companies nowadays are moving towards digital twins. So this is a kind of digital twin that I'm showing you in this presentation. So if you see that a bottle filling plant, if suppose they have a production of 100 bottles per day, so they have their entire design being done in Automation Studio, the entire pneumatic design with different sensors mounted here. And then they can also see how many bottles are produced so far. I'll just play another video here. And the count will come out here. So this is the entire machine that they can create. Now let us say if the demand is more, if they want to create 200 bottles per day, So what all things will they have to change? So first thing that they'll have to do is they'll have to change the speed of the conveyor line. So for that they'll have to change the frequency of the VFD, that is the variable frequency drive that comes with the motor, which will change the speed of the conveyor. And then once you change the speed of the conveyor, you will also have to change the speed of the pneumatic cylinders here, which will match which will match the speed of the bottles coming on the conveyor line here. So if you can increase the speed of the cylinders here, which can match the conveyor speed as well, that will help them to produce more bottles in a day. So such kind of troubleshooting scenarios or such kind of different scenarios they can try to simulate in Automation Studio, which will help them to get a realistic simulation environment or a realistic digital twin environment, which will help them also to make that particular changes on the actual assembly line of their plant. So there are multiple benefits of the software in multiple industries like packaging. Now this is one example that I've shown you for a bottling plant that we have built. So I hope so far it is clear. I'll wait for your questions. If you have any questions, you can ask me anytime. Fine. So maybe I can move ahead with the presentation. So if you go on our website and if you click on the products professional edition, you will see that there are different applications in different industries. For example, if I click on agriculture here, it will automatically give you the different applications in different companies. For example, your power unit, transmissions, braking actions, your auxiliary functions of attachments. You have the types of machines like combine harvester, tractor, your accessories which comes with the tractors. So all these things can be simulated in Automation Studio, and that is how most of the companies find this software useful for designing and simulation purpose. Also, one more important feature that the students will get here is not only they will get to know the brain behind the entire building of the machine, how the machine works, what are the components used, but also there is sometimes some companies use the software and then they also produce the bill of materials, documentation part. So all those things are also very useful when it comes to working of industries. So bill of materials, documentation, report generation, all those things can also be very easily done in Automation Studio. Now this is specific to industries. When it comes to research and PhD uh, side, then you can also make your own systems, build your paper presentations, see the simulation, capture the results, make your own paper presentation, make your own project on what you have done using Automation Studio. So this will also help you in that way, as in if you want to make a particular paper presentation at a conference or a publication as well. So in the defense side also we have a few companies which are actively using. In India also we have companies like L&T Defense who use the software. So definitely the students will get good employment opportunities if they learn the software in and out, if they know how to design a particular system, how it works, what are the different components required, what is the logic behind it, and so on. So I think I have mostly covered a majority of the topics for the industry oriented use of Automation Studio. I've also shown you different industries that use Automation Studio software. And Anil sir, if you want to add to this, you can add further, or we can go for the Q&A session.
Yeah, nothing to add. You have covered most of the applications, and basically which I covered is only hydraulic part, but you touched upon all the things, defense and other stuffs, mechanical manager also.
Yes.
Yeah. Any questions for us? Like,
Any question from participant? Ask ask one by unmuting itself. Uh, okay. It is great privilege to having you here, sir, and sharing your experience with us. I would like to express my heartfelt gratitude to our honorable guest, uh, Mr. Anil Ambore sir and Shardul sir, for accepting our request and sparing time out of his busy schedule to address, guide, and inspire us. Thank you very much, sir,
thanks.
for joining us.
Thanks for giving this opportunity. Yeah.
Thank you for giving the opportunity.
And some announcement for participant feedback form will be shortly displayed on Telegram group. And tomorrow session will be start 10 o'clock.
Uh, Participants, if you check your mail, the feedback link has already been sent to you. You can just fill that up. Also, the link for tomorrow's session is also displayed. Thank you.
Thank you. Thank you. Thank you, team. Bye.